Today's video has a few example problems from the Algebra journal that I've kind of chosen to help us see how these properties of exponents get utilized. So the first one I have here is question 2, and in question 2 we have a parenthesis to the 0 power. So be careful when you see 0 powers or powers next to parentheses, or even powers that are not next to parentheses, because the power only works on whatever it is closest to. So in this case, this parenthesis is going to get that 0 power, that entire thing. So anything to the 0 power is equal to 1. Now I say be careful because if you take a look with number 6, the next one I've identified, we have a -2 power, of course, and that is only acting on whatever it is closest to. And what it is closest to is the 3. Which basically is me saying that that -2 power is not going to act on the negative sign. That negative sign is going to remain in the numerator. So you may want to think about this as negative 3 to the -2 power over 2 to the -3 power. Maybe more like this. Maybe an even better way of looking at that is -1 multiplied by 3 to the -2 power over 2 to the -3 power. So we know that 3 to the -2 is not in the correct part of the fraction. It's in the numerator right now. So it needs to be on the denominator with a positive power. So we'll just help it out and put it on the denominator with a positive power. Now this 2 to the -3 power, just like the 3 squared, 2 to the -3 is on the wrong side of the fraction bar because it has a negative power. So we'll just put it in the numerator with a positive power. And now we could take that -1 and return it just to a negative sign. So this is just -2 to the 3rd power over 3 squared. Taking a look at number 7, we've got 4 to the -1 power. We've got on the denominator, now I'm going to turn that into -1 multiplied by 7 to the 0 power, because that -1 is not inside of a parenthesis. So, or the negative sign is not inside a parenthesis. So I'm okay writing that as a -1. The first thing to simplify is a 7 to the 0 power. That's just equal to 1. And just like before with this negative exponent, we're being told that this 4 to the -1 is on the wrong side of the fraction bar. So we're going to help it out by putting it on the denominator and giving it a positive power. Now there's nothing left on the numerator, so we're going to put a 1 there to take its place. On the denominator, we have -1 times 1, which is just -1. And now we also have -1 multiplied by 4 to the 1, so I can return that -1 and just make it a negative sign. So that's just -1/4. Moving on to number 11, we've got 6 times a to the 0 multiplied by b to the -2. Now I see that negative power, and that immediately makes me think I should put a fraction bar on here and just rewrite everything. 6 a to the 0 b to the -2. I'm going to go factor by factor here and figure out if I need to do anything to it. Starting with the 6. Now the 6 doesn't have a negative exponent. It doesn't have any exponents at all. So really, it's looking pretty good. We don't have to do anything to 6. A to the 0 power, however, well, you can see that has a 0 power. And anything to the 0 power can be simplified into 1. Now be careful. I'm going to keep those multiplication dots, or I'm going to put multiplication dots around the 1 so I don't actually accidentally make a 61. b to the negative 2 is on the wrong side of the fraction bar, which is why I put the fraction bar there to begin with. So this really belongs on the denominator with a positive exponent. And on the numerator, I can simplify that 6 times 1. That's just 6. Okay, so let's take a look at the next one. This looks like we're going to be going to question 16 next. So let's zoom in over here, and let's see what we got. We've got negative 2 on the numerator to the 7th power, and negative 2 to the 5th power on the denominator. Now, don't be fooled, because these are two exponents to this for the same base. Notice how they are both negative 2 to a power. So if we have the same base, we can just subtract, keep that same base, and just subtract the exponents. 7 minus 5 is 2. So this is the same thing as negative 2 to the 2nd power. Moving over, we're to letter C. Sorry, not letter C. I see all those C's and it just kind of made me crazy. Moving on to question 20, we've got a whole bunch of letter C's here. So we're going to simplify that. We'll start with the numerator. If I'm multiplying two exponents with the same base, they both are base C, I can just add the exponents. So my numerator here really should be C to the 7th power. The denominator is C to the 6th power. I'm not doing anything with the denominator, I'm just rewriting it. Now we have the same base on the numerator and the denominator, so we can just subtract the powers just like we did in that previous problem. So this is C to the 7 minus 6 power, or just C to the 1st power. Now the last one we're going to look at is negative 3f to the negative 3 power. So be careful with this one, because we do see a negative 3 power being applied to a parenthesis. So this entire parenthesis is going to be on the wrong side of the fraction bar. I'm going to write it underneath the fraction, or on the top of the fraction bar. And I'm going to move the entire parenthesis to the denominator and give it the positive power 3, which means I've emptied the numerator, so I should just give it a 1. Now there's still more that we can do here, because we have the power of a product. So we can just distribute that power to everything in the product. However, there's a negative sign there inside the parenthesis, so I want to be extra careful with that. Extra careful means we're going to treat that negative sign like a negative 1. So the first thing that's going to get that 3rd power is going to be the negative 1. The next thing to get that 3rd power is going to be the 3. And the last thing to get that 3rd power is going to be the f. Now for some reason, negative 1 to the 3rd power makes people uneasy. So we're just going to multiply that out. Negative 1 times negative 1 times negative 1 is negative 1. So we'll put a negative 1 here. And let's multiply this 3 cubed. 3 times 3 is 9. 9 times 3 again is 27. So we'll put a 27 here. And then f to the 3rd power. Now again, like I said, with this negative 1, for some reason, we can, well, not for some reason, but we can go ahead and just multiply that by 27. So 27 times negative 1, that's just negative 27. So that's all of our problems. These exponent problems do tend to go fast if you have your basics solid, and hopefully by now we've got all of our solid basics. So we will see you next time here on the Algebra channel.